Hi everybody, today we are going to talk about angles of elevation and depression. So angles in elevation and depression are actually very similar, except one is coming from a horizontal going up and one is coming from a horizontal going down. So an angle of elevation is the measure of the angle formed going up from a horizontal. So let's imagine your horizontal is something like the ground. Your angle would be this one going up. This is your angle of elevation. Now for an angle of depression, you have to be really careful because one, we have to know that this angle of depression always comes from a horizontal. You always have to have a horizontal line. If there's not one, you should draw it in. And this angle goes down from the horizontal, so it's going down this way. So I know they look very similar, and they do both come from horizontals, and that's extremely important. But an angle of elevation goes up from a horizontal, and an angle of depression goes down from a horizontal. So now we're going to try a couple of word problems that use angle of elevation or depression. So a key to this is going to be drawing a picture and then labeling our parts appropriately, and then we're going to be using SOHCAHTOA to solve for the missing part. So it says, from a point 80 meters from the base of a tower, the angle of elevation to the top of a tower is 28 degrees. How tall is the tower? So let's start with this first part. From a point 80 meters from the base of a tower. So that means that we're going to draw some tower. I'll draw it in black. So there's our tower. And it says from a point 80 meters from the base. So remember, base means the bottom of a tower. So here's the ground, okay? And of course we know that a tower and the ground should make a 90-degree angle. So it says from a point 80 meters from the base. Here's the base, so let's imagine there's some point over here where this distance is 80 meters. So from this point, it says the angle of elevation to the top of the tower is 28 degrees. So from this point to here will be how our angle is formed. So go ahead and draw that in. And that angle of elevation, so remember this angle of elevation is from a horizontal going up. So this angle of elevation is 28 degrees. So they would like to know, how tall is the tower? They want to know this side. So now if you think about it, this is just like the problems we've been working on. We have a right triangle and we have an angle on one side. We have to use SOHCAHTOA. So I like to label our sides. So I see that this is opposite from our angle, so I'm going to label it O. I can see that this leg is adjacent to our angle. So I know that using opposite and adjacent, we will have to use tangent. So we can say tangent of 28 degrees equals x over 80. Then we're going to multiply both sides by 80. And then from here, we can use our calculator to give us a decimal approximation, and we'll round to the nearest tenth. And we should get 42.5. Now, just to answer it completely, we have to go back and look at the units, and the one unit we were given is m for meters. So our answer is 42.5 meters. All right, go ahead and pause the video and give this problem a try. Okay, so for this one, it says that a ladder that is 20 feet long is leaning against the side of a building. So I drew on my building, here's the ground, it should be a right angle. So here's my ladder and it's 20 feet. If the angle formed between the ladder and the ground, so this angle, which is an angle of elevation, is 75 degrees, how far from the bottom of the ladder to the base of the building? How far is the bottom of the ladder from the base of the building. That's from here to here. Notice they did not ask how far up the building does it land. They went from the bottom of the ladder to the base, meaning bottom of the building. So for this problem, I can see that I have adjacent and hypotenuse. Let me label that in. This is the adjacent side. This is the hypotenuse because it is opposite the 90. So for this problem, we know that we need to use cosine. So cosine of 75 degrees is x over 20. Multiply both sides by 20, and then your calculator can give you that decimal approximation, 5.2 feet. Okay, let's try another one together. This one says, when the sun is 62 degrees above the horizon, a building casts a shadow 18 meters long. How tall is the building? So this one, we do need to know what a horizon is. Horizon sounds a lot like the word horizontal. So it's kind of just the flat ground. So something like this. It says the sun is 62 degrees above the horizon. So this is going to be an angle of elevation. So let's imagine that our sun is up here and it's 62 degrees above. So this angle of elevation right here is 62 degrees. Now this says a building casts a shadow that is 18 meters long. So let's imagine that there's some building right here. So you know that when the sun hits this building, this is the shadow it's going to cast. And the shadow falls on the ground. So this length is our shadow, and that's 18 meters. They're asking us how tall is the building. So that's going to be right here. And of course, the building and the ground should form a 90-degree angle. So once again, we need to set up our equation using SOHCAHTOA. I see that this is opposite, and I see that this is adjacent, which means that we are going to need to use tangent. So tangent of 62 degrees equals x over 18. We're going to multiply both sides by 18. And then we can get a decimal approximation from our calculator. So x is approximately 33.9 when you round. And then we'll write our final answer with our units, 33.9 meters. All right, one more together. This says the angle of depression. Now we have an angle of depression from the top of a tower to a boulder on the ground is 38 degrees. So let's start by drawing that out. So here's our tower. So of course the tower is on the ground, and this should be 90 degrees. Now here's the tricky part. When we're given an angle of depression from the top of a tower, which is here, to some boulder, let's say is here. So we know it's going to be this angle. It's really, really easy for people to say, oh, this is my angle of elevation, or angle of depression, but that's totally, totally wrong. The reason why, if you have to remember, an angle of depression always comes from a horizontal. So we actually have to draw in our own horizontal like this. You have to draw in the horizontal. So this right here is our angle of depression. So be very, very careful. It always needs to touch a horizontal. So from there, let's see what else we can fill in. It says if the tower is 25 meters high, how far from the base of the tower is the boulder? So they tell us that the tower is 25 meters. And they would like us to find how far is the base, how far from the base to the boulder. So they want us to find this. Now look at the triangle we have and look at where our angle is. We have two options here. We can subtract from 90 and figure out what this angle is, or we can simply create a new right triangle over here. And if this side is 25, I know that this side is 25. And if the bottom is x, I know that my top is also x. So from here, we can use that triangle in red to help us solve. So I can see that this is opposite, and I can see that this is adjacent. So we're going to use tangent again. Tangent of 38 degrees equals 25 over x. Now this will have two steps to solve. First, we need to multiply both sides by x, and then we need to divide both sides by the tangent of 38. From here, we can get a decimal approximation from our calculator, and it should be approximately 32.0 if you round correctly. So our answer is going to be 32.0 meters. And I know that it seems like, well, if it's 0.0, do I need to write it? And the answer is yes, because we have to show that we rounded. So technically, you do need to have that decimal point. All right, so go ahead and pause the video and see if you can give this problem a try. So once again, be very, very careful. When they say angle of depression, that angle needs to be touching a horizontal. It's very common to write the angle of depression here, but that's against the vertical. So you have to draw in your own horizontal and then make a new right triangle up here. So this is our angle of depression. They say that the car, here's my car, is 50 meters from the base of the building. If this is 50, so is this. And they would like us to know how tall is the building. If this is x, so is this. So then we can set up our ratio using tangent, multiply both sides by 50, and then use your calculator to give you a decimal approximation of 26.6 meters. All right, I'd like to do one more problem with you because this one we're actually finding the angle, so it's a little different. So this says a 100-foot building casts a 300-foot shadow from the sun. So let's start by drawing our building. And let's imagine, so we'll call it 100 feet. And let's imagine that the sun is somewhere over here. So we can see that with the sun coming in like this, it's going to create a shadow. I'll do that all in yellow actually. It's going to create a shadow right here. So this at the bottom is our shadow. And it says that that shadow is 300 feet. So they would like us to find the angle of depression. So remember, they would like us to actually draw in a horizontal, and we can draw in a new vertical here. They want us to find this angle. So I'm going to call this theta. So remember, the angle of depression needs to be from a horizontal. So this is a big rectangle. So if this side is 100, so is this side. If our bottom is 300, so is this side. So now that we have our picture, we can set up our equation. So I can see that this is opposite, this is adjacent. So we're going to use tangent again. Tangent of theta, we don't know what the angle is opposite over adjacent. So remember, this is the time where we're going to swap these two terms and we're going to use arctangent, our inverse function, which we will always use when we are finding the angle. So remember, your calculator can also do arctangent. So you plug it in to get a decimal approximation, and we should get approximately 18.4 degrees because it is the angle. Okay, that is all for today. Thank you very much for watching.